that, and this doesn't make any sense.
Vedanti's in my class, and she was just grilling Lawrence Vedanti
Oh, yeah.
about like the school balance scorecard, and she's like, "Why does it do this?" And Lawrence like, "I didn't make it." Like, but like, I'll get back to you and try to see if I can find out.
You cannot just give up after like, you're like, we can't, when it makes around 5 years, like, whatever. I think our school card might be good.
I get mine. I got like,
Yeah, I've got a pretty good group. Yeah. And also, you don't know, like, if everybody's getting 100s on these
yeah.
ringers out there.
But on that test, but apparently
Oh, he was very generous in his
very generous. Yeah,
his
grader.
partial credit.
Yeah.
Yes, very.
I showed up in person too. I was like one of two people that showed up.
Okay, I was gonna
He
go
was
in
super
person, but I
appreciative
go.
of that, but like, I don't like, he said he graded honestly, so I was like,
Okay.
I don't know if he's extra nice to me.
You showed up, yeah. Put your name, couple name tag.
Yeah. It's like-
Yeah, this is me. I'm in person.
He was not taken.
Okay, yeah, I was gonna come in and take it in person, but it was like, we're down I think that day. It's like,
I was just like,
That was the only sucker that showed up.
okay, yeah.
One of them. I was like, am I at the right place? And then-
Everybody know what, like,
oh, yeah, secret strategy.
He's not a strategy. He's not a
You told me
strategy.
that.
He's like, John, do we have assigned seats for this class? I'm like, no. He's like, I haven't been in person. I thought like for the test. I don't know if he's my, I don't know if he's my accounting class. And like, then Willis stands up and it's like going through like the whole thing. It's just the two of us, and then Quinn. And then he goes, oh, I need to be. I'm in strategy. Just gets up and sprints out.
That's pretty good, yeah.
She's like, oh, well, we can meet. I was like, I can't. Yeah.
Went to the German podcast today.
Yeah. so I go with that.
Great ones.
Yeah. Watching college basketball. Yeah. The Big Ten bar. It's like playing like just like Big Ten game. Obviously, I wasn't complaining, but big win for you guys.
Yeah. Fun game.
That was a sick game.
It was so fun. It was just like a really good game.
The one seed.
Sure. I have my days confused. She's like,
Their position for a one seed.
It's always one state.
I'm gonna do it.
I don't know, you guys are ranked
I was
fourth, right?
very confused on my days.
Okay, they're.
Oh, she was fourth?
Yeah, both of them.
We'll both be one seeds, yeah.
I don't know if anyone can beat Gonzaga,
Gonzaga's playing like Santa Clara right now.
but they're also massive. They killed, they
No, I
killed
know.
Virginia, they killed Iowa.
Yeah, they're good. Well, I was actually not
They actually turned out. to be-
Gonzaga is the best team, but it's, you never want to go in the tournament undefeated. That's like, it's just, it is, it like, it is kind of an essence. I mean, maybe they can get shaken off because it's gonna be such a weird tournament with like playing at like church gyms. But yeah, I would not want to go in the tournament undefeated.
They bubble in Indy.
Yeah, so they're staying in the city.
What gyms are gonna be Butler, like obviously the Pacers, the field house.
Yeah, they're playing in Bloomington, Indiana. Yeah, which would be cool. That's a cool,
really cool.
Arena.
Yeah.
I guess
Low capacity crowd, I think we're 25%.
for the Final Four.
Yeah.
I think so. Yeah, they're gonna do like baseball did for the pennant World Series.
Kevin Daly, you hear me?
Yep, I got you.
Allison Taylor, Julian Benzinger, you hear me?
Yep, loud and clear.
I can hear you.
Hope everybody survived the snow. If you did not survive, raise your hand. I'm a little bit behind grading. I should finish that tomorrow or Wednesday. Set 4 individual. Let's look at data tables, page 41 of the class pack. Let me skim the directions and then go demonstrate them, and then come back and read the directions more carefully. Automatically perform a series of calculations using one formula, which refers to one or two input cells and one or two series of values. One variable data table, usually called one-way data tables, have one input series and usually in a column, and the answer is placed to the immediate right of the input values. The formula refers to one input cell, and there is some design requirements. Let's jump to data tables. Deloitte specifically asked me to teach data tables to the Masters of Accounting students. I teach an Excel tutorial, about a half a class worth of material, 1 hour. It's a non-credit, but it's got the equivalent material of half of the content of this course. Data tables seem to be popular. However, after we learn them, you'll see that they can't really do anything more than formulas can do. They're just easier for non-technical people. Let's jump right in with an example. So I'm in sheet data table example and in class. Let me organize. Start with a one variable data table. I am considering spending $10,000 to rent a machine. If I do, I will manufacture products that require $200 in materials, sell for 225, resulting in a $25 contribution to profit and overhead per unit. 225 minus 200 is $25 contribution. I'd like to know the break-even point, the point at which my revenue will exactly cover my fixed costs of $10,000. I chose a fairly easy example so you could confirm the answer in your head. In the red border cell, named quantity, I place a number. Suppose I sell one item. The calculated profit is minus 9,975. That's minus 10,000 for the fixed cost, plus 25. Suppose I sell 100. Then I lose 7,500. I spend 10,000, I gain 2,500. Suppose I sell 300, etc. By trial and error, if this was important, I could determine that the break-even point is 400 items sold. If I can sell more than that, there will be a net contribution to profit and overhead. If I cannot sell that many, I will lose money. Okay, let's use that to illustrate a data table. First of all, let's look at the 4 named ranges, all of them single cell. C4, look at the name box, is called sales price. C5 is fixed cost. C6 is named variable cost, one word. C9 is named quantity. The formula is equals quantity, red border cell, star sales price minus variable cost. That is 25. 225 minus 200, minus the fixed cost. I put the formula in one cell, defined a new column. Red, good enough. Put the formula in a cell. To the left, one row down, I put a bunch of values at which I want the formula evaluated. You have a formula with various input cells, one of which you want to do sensitivity analysis on. And that, in my case, is production quantity. I want to evaluate the formula at 0 and put the answer to the immediate right of 0. So if I produce nothing, I lose 10,000. If I produce 100, I lose 7,500. Read the comment as you hover. You might have to resize it. Substitute 100 into C9, the red border cell, and calculate G3 and put the answer in G. Calculate G3, put the value in G6. All right. 0, the answer is actually to the immediate right. 100, the answer to the immediate right. We see the break-even point and so forth. How many of you in the room, show of hands, and a chat vote, Zoomers, consider yourself pretty good at data tables? I see no hands in the room. Zoom. Or chat. Nobody answered me. Give me a yes or a no. Zoomers, please. Yes, I'm familiar with them, or no, I'm not familiar with them. I've got a statistical sample, the first 5 or no. Okay, good enough. I will lecture at a slow pace. Let me check the accuracy. Something's wrong. Substitute 0 into C9, yes, the red border cell, and put the answer in G4 to my immediate right. Correct. Substitute 100 into C9, calculate G3 and put it into G5. Yes, the comments are correct. All right. That's a one variable data table. There prototypically is there is an unused cell inherent in this design. Prototypically, it's a label, but you can leave it blank or put whatever you want there. For these values in yellow and orange, F5 through F14, put whatever numbers you want. The formula will be evaluated at these values and the answer put to the immediate right. Let's recreate the data table. Let's clear G4 through G13. Delete G4 through G13. Turns out I need these yellow and orange values. Let me go to review. Hide all comments. Select the unused cell at the upper left, the formula to the immediate right, and as many cells as you want down. The left-hand column must be populated with legitimate values. The right-hand value will be populated. Data tab of the ribbon. What if analysis, data table. It's kind of hidden. What if analysis, data table. And it will ask you 2 questions, the row input cell and the column input cell. We have, in this example, a 1 variable data table, not a 2 variable data table. The column input is C9, the red border cell. Let me not hit OK yet. I want 0 to go into C9. You see the moving marquee, don't you? I want 100 then to go in C9. Iteratively, put 200 in C9, evaluate the formula, and put the answer to the left. I'll print screen, Control V. There are my data table settings. There are the answers. Intentionally fairly simple examples so you can confirm. The data show that the break-even point is 400. Let's look at a two-variable data table, informally called a two-way data table. I have one formula, which I put in C29, several inputs, two of which I want to do sensitivity analysis on. A one-variable data table had one input that I wanted to do sensitivity analysis with. A two-variable data table has two variables I want to do sensitivity analysis on. I'm considering buying a house, $250,000, annual interest rate 10%, years financed 10. The formula is equals minus the PMT. Without the minus, the payment itself would become negative, and all through the table would be negative, and I don't feel like looking at that, so I'll say equals minus the PMT. And I'll use the argument tooltip to answer the question. What is the interest rate per compounding period? It's C23 over 12. I do want the monthly payments. Monthly compounding, 10% divided by 12 months in a year. N-PEER, the number of compounding periods, 12 multiplied by the number of years, C24. And finally, the present value, the amount of the loan, C25. In the first example, I had the formula in a standalone cell, and I repeated that formula in the data table. G3 has identical content as C10. In the next example, I have the formula only in the data table. Either way is fine. Given the formula, I put a bunch of input values in the column immediately beneath the cell with the formula, and values in the cells immediately to the right of the formula. And I have to identify that these are years, 10 years, 11 years, 12 years, 13 years, and so forth. Annual interest rate, 7%, 8%, 9%, 10%. Let me recreate the table. I clear the data table itself. I don't clear the formula. I need it. And I need these values in yellow fill. I select the range, including the formula at the upper left, and all the values that I want. Data, what if analysis data table. Answer the two questions, the row input cell. Those are years. So I'll give it C24. The column input cell, those are interest rates. I'll give it C23. I caution you that one of the settings you can choose in calculation mode is automatic except for data tables. That's rare, but about every 2 years, I get some student who gets an error message when he or she creates a data table. There is a setting which you should make sure is automatic, not automatic except for data tables. Data tables do slow you down. If you have a really old clunker of a computer, you might want to choose that option. Your client, your boss might have chosen that option. Calculation can be automatic or manual or automatic except for data tables. Take a moment and study this, please. I'll give you 3 minutes till 19. Notice, like a pivot table, you cannot delete part of a data table. It'll give you an error message. At a lawyers' convention, terrorists kidnapped a bunch of lawyers. They threatened that if their demands were not met by 5 p.m., they would begin releasing 1 lawyer per hour. Let's work an in-class problem. It's intended to be a black box illustrating synergism. Someone who understands a data table but does not understand the details of the financial analysis cannot do this job. Someone who understands the details of the financial analysis but does not understand data tables cannot do this job. But between the two of them, they can do the job. Maybe, maybe not, this black box analysis will make sense to you. We are considering buying a company. S10 through X10 contains projected cash flows for a company. The terminal value in X10 is assumed to be 10 times projected EBIT, earnings before interest and taxes, CP11 and P12. EBIT 10 times. The end of year 1, the projected cash flow is 482 million. The end of year 2, the projected cash flow is 654 million, etc. End of years 3, 4, and 5. It is considered unreasonable to ask the question, what is your projected cash flow in 30 years, 40 years, 50 years? Nobody can answer that with precision. So the terminal value is assumed to be 10, although 10, I'm going to change, times EBIT. I hope you all know the finance term 1 divided by the quantity 1 plus I to the n. The present worth at interest rate I of money to be spent in n years. 1 divided by 1 plus I, the quantity to the n, is the multiplier. The equivalent Excel formula is 1 divided by 1 plus P10. That's the interest rate, the discount rate for NPV calculations. Hat X9. X9 is 5. The 5 repeats twice intentionally. Let me housekeep a little bit. The projected cash flows at the end of years 1 through 5. And then at the end of year 5, the EBIT is, or the estimate is 10 times 800. We need to take the present worth of this to back it up to times 0. That is a black box. I didn't teach that. I suspect most of you know that, but if you don't know it, that's okay. I want you to take this formula in P13, which is the NPV at interest rate P10 of the cash flows S through W10 plus the present value X10. That is the present value at the end of time 5 of all future cash flows divided by 1 plus P, the interest rate raised to the 5th power. Assume that's a valid formula. Reevaluate that formula for different values of, let's be careful here, the formula has 3 inputs. 11% discount rate, multiple for EBIT 10, EBIT itself 800. The answer is $7.3 billion. Not surprisingly, somebody wants us to do sensitivity analysis to evaluate the same formula at different discount rates, at different EBIT multipliers. Even if you don't understand the details, even if you don't understand why, you should be able to evaluate this using a black box formula with a trusted colleague convincing you that the formula you're evaluating is valid, and you are a trusted colleague of the other guy. He's trusting you to do the data table correctly. How many in the classroom have seen this type of financial analysis? I think it's taught in corporate val. I've got 1 out of 5. Zoomers, you can simply vote yes. If I don't see a no, then I'll assume you did not vote. No, if I don't, you may simply vote yes if you've seen it, sorry. While I'm hunting up the vote tally, please start working the problem. No one has voted, so I'll take that as no one has seen this. Where'd you learn it? In corporate val?
Real estate class.
Okay. Maybe my question is not fair. A lot of people, myself included, don't remember where they learned everything they know. How do I know 4 plus 3 is 7? Who taught me that? My mother, my father, my kindergarten teacher? So it maybe is not a fair question. All right, let me work the problem for you. For the formula, I will use a reference to the existing formula. In R19, I will enter equals P13. I'll select the range with the formula and the cells beneath and the cells to the right. Data, what if, data table, and I will answer the 2 questions. two-way data tables have two series of input values and two questions. The rows, those are EBIT multiples, so that would be P11. A column, those are percentage interest rate, discount factors. So P11, P10. All print screen. Upper left corner, 7649, lower right corner, 7760. The advantage of data tables is not much to an expert at Excel, like all of us. You can do the calculation with partially relative, partially absolute cell references without a data table. But a lot of non-technical people who will maintain the spreadsheet are not as good as you and I are. And if Deloitte wants me to teach it to the masters and accounting students, I'm convinced it's an important topic. You ought to know something about data tables. You ought to know how to create a data table. Let me talk for a little bit longer. Now that you've seen them in practice, the directions make more sense. One variable data table, a formula with empty cells beneath it to contain the answers, and one column to the left, one row beneath the formula, input values to substitute into the formula. And the answer goes to the immediate right of the 11. Substitute 12 in the formula, get the formula value. Four-pass group what-if analysis. Answer one or both of the questions. Break-even profit analysis, financial calculations. Formula, values beneath, values to the right. And though this is outdated, it is correct on my Office 365 answer. 2 minutes, and then we will go to a brand new topic of simulation. Simulation. Let me begin with my teaching style of showing you some examples and showing you what you were supposed to read before class, and then going back into the details. Let me look at some motivators. Merrill Lynch Global Bank Group, in particular the Merrill Lynch Management Science Group within the Merrill Lynch Global Bank Group, won an award for developing a Monte Carlo simulation. That's exactly what we'll be talking about today. Using a mix of operations research management science techniques, and the model, the business analytics, was able to free up about $4 billion in liquidity. So they saved the annual interest on $4 billion. If the interest rate was 10%, that's pretty high today. They saved $400 million per year. Even at 1% interest rate, annual interest, I think annual interest is more than that. They would have saved 40 million per year. Simulation used by Merrill Lynch. Other motivating, I had a guest speaker from the Saturn Corporation of General Motors. He made the extraordinary statement that within the Saturn division, no request for capital, for money for capital improvements would be ever approved unless backed up by a simulation study. That was actually for a separate course. There used to be a one module full course on simulation. Eric Johnson used to teach that. Do you know that he was an assistant professor here before he left and then came back as dean? I inherited the course from Eric. All right, so guest speakers attesting to the popularity of it. I think that simulation is not as commonly used as optimization, but it is an important topic, and the amount of time I spend on simulation, 2.5 classes, whereas I spend much more than that on optimization, reflects my opinion of the relative importance of it. I will also say, since it's relatively late in the course with the final exam coming up, the questions on simulation will be elementary rather than advanced for simulation. All right, I asked you to read a typical sales revenue on a typical day is $1,000. That happens 75% of the time. Exceptionally high sales occur the other 25% of the days, $1,500. This is the formula we will use to simulate sales during a future period. On day one, equals if RAND. I haven't taught you the RAND yet. That is a random decimal. 0 point something, 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 something. Equals if RAND is less than H2. That is 25% of the time. If RAND is less than H2, 25%. That will happen 25% of the time. The value, if true, 25% of the time is $1,000. G2 is actually 75%. I misspoke, sorry about that. H2 is actually 75%. Balloon is in my way, but I should know better. 75% of the time, we get 1,000. The other 25% of the time, we get 1,500. There they are with conditional formatting to prominently highlight the 1,500s. The F9 key is supposed to recalculate. It does most of the time, but on several occasions in various classrooms in the Owen School using the Podium PC, the F9 key does not work. And this was not a Mac Windowsy issue. An alternative is go to any empty cell and press the delete key. There's nothing there, but so you're not deleting anything, but it will force recalculation. Past sales have been 1,000 or 1,500. That's what we're going to be doing in simulation. Cover the next sheet. No, I'm not going to do that. Let's go back to the class pack. I'm not going to cover the next sheet yet. I want to address what is simulation and why is it important? I answer those questions. Simulation is performing experiments on a computer model to understand how uncertainty is impacting you. There will be uncertainty directly within the analysis. We've not seen that before in our linear programming solver problems. Now we're going to have RAND directly in the Excel sheet. The uncertainty will be evident. I'll talk about it later. Continuing the outline, we will look at 5 ways to generate random numbers. This is not a course in statistics. You don't have to know much about probability statistics. You don't have very little. This is a course on implementing analyses, simulation in this case, within Excel. But you do need to have a vague idea that uniform means every value has equal probability. Compared to the normal, where some values have higher probability. You need to be vaguely aware of that. Uniform 0 to 1. Uniform between any 2 numbers, 15 and 20, for example. Empirical, that means you specify the probability. I think the values will be 50 with probability 0.2, or 60 with probability 0.3, or 70 with probability 0.4, whatever. You specify any probabilities you want. Positive numbers that add up to 1. That's what an empirical distribution is. The normal distribution, remember mu and sigma in core stat? Of course, no one answered that question. And then we're going to look at the if in conjunction with the RAND. It's late in the course, you'll be expected to know only how to do extensions of what I do. Simulation is descriptive. Linear programming is prescriptive. A doctor writes a prescription saying, take 2 pills every morning and come back and see me in a week. I like to modify that, drink two big bottles of Jack Daniels every day for a week and come back and see me. That's my prescription. All right, a doctor prescription. Linear programming is prescriptive. It recommends a solution to you. Simulation is descriptive. It tells you how good your solution is. You specify solutions on your own. For example, a histogram of a new net present value of a new product development on the right. Let's look more carefully at these numbers. The most likely value is 7.3 million. These are in thousands of dollars. The tallest bar, $7.3 million. We might lose $2 million, parentheses, minus 2,200. There's a very small chance that this project will lose money or will make a negligible amount of money. But there's a good chance that it'll make a lot of money. The expected value from probability, I will not ask you directly any questions on probabilistic concepts like expected value variance. I'll expect you to understand those terms when we go to the normal distribution. Days required to meet an order or minutes in the queue left. Many customers will wait 6 minutes. Some, almost as many, will wait 5 minutes. I'm looking at the bar height. Nobody will wait 1 minute or less. The smallest possible waiting time is 2 minutes, a few customers. 3 minutes, more customers. No one will wait 10 minutes. Days required to meet an order or minutes in the queue. An alternative interpretation, it'll take, surely, most likely it'll take 6 days. The most likely value is 6, but it might be 5 or 4 or 3, and it could be 2. It will not be 1 day. It will not be as long as 10 days. Simulation describes how good your solution is. Why is it important? Many systems have uncertain inputs. Can you think of some examples of uncertain inputs in simulation? What's the exchange rate going to be, Chinese renminbi per US dollar on June 1st to this year when we are obligated to pay a bill in renminbi? Exchange rates, interest rates are unknown. Cash flow requirements, customer demands. If there's only a little bit of uncertainty, we can ignore the uncertainty. If there's only a little bit. We always, so far in this course, in the linear programming model, we ignored uncertainty in the analysis. That's okay if there's only a tiny bit of uncertainty, but it's not okay if there's a large amount of uncertainty. Let me show you two examples of this underlying principle. The takeaway is you have to use uncertainty directly within the model. If you represent uncertain values with the average value, you get the wrong answer, unless there's only a tiny amount of uncertainty. If you represent uncertain values with average values, you get the wrong answer. Let me look at a sarcastic example. This guy is drinking heavily and walking down a heavily congested street. He's thrown away one bottle already. He's weaving left and right. So far, he's still alive. The uncertain value is the future position of the drunk. Will he be here? Will he be here in front of the green flag? He'll die if he steps to his left. He'll die if he steps to his right. He'll get run over. But if he remains exactly on the center line, he's okay. The average value is on the center line. If you ignore the uncertainty, if you ignore the fact that often he goes way to his left and way to his right, if you ignore that fact and simply represent his future position as on the center line, you conclude that he lives. That is blatantly false answer. He's going to be dead momentarily. Now let's look at a more serious managerial example. I wanted to go back to the class pack. It's quite similar in concept. We are a pharmaceutical company. We sell to individual retail drugstores. We stock cases of a drug for which demand is uncertain. I don't know how many customers are going to want to buy this drug. Excuse me. Average demand has been 5 cases per month, but sometimes demand is 4 or 6 or 3 or 7 or 2 or 8. At the end of the month, if demand has been less than 5, then we have too much. We stock 5 cases. If demand is less than 5, the cases expire and we can't just throw them out the window. That's illegal. We can't just put them in the trash can. They have to be destroyed, properly destroyed, in an environmentally friendly way at a cost of $50 per case. If demand exceeds 5, that means we don't have enough. Once again, we stock 5. If demand is 5, that's great. We lucked out. If demand is less than 5, we have too much. We have to destroy and pay money for each excess case. If demand exceeds the 5 that we stock, we are short units and they must be airshipped in at a cost of $100 a case. Let's look at a simple analysis. In month 1 through 6, remember we stock 5. If demand is 5 in the simulation, demand is 5 in month 1. We're not short anything. We don't have any excess. Our extra cost is 0. In month 2, simulated demand is only 2. We're not short anything. We have extra 3. They have to be destroyed at a cost of 3 times $50. In month 3, simulated demand is 7. We are short 2. Remember, we stock 5 every month. We don't have any excess. We're short two. 2 times $100 is our cost. In month 4, simulated demand is 5. We're not short anything. We don't have any excess. Cost is 0, etc. We have a bunch of zeros and positive numbers. The average that we will get from our analysis is not 0. The true average cost is positive. But if we made this mistake, if you represent demand as equal to 5, equal to its average value, that is, if you say demand in month 1 will be 5, demand in month 2 will be 5, demand in month 3 will be 5, the average value, you get the wrong answer. You get 0. And 0 is the wrong answer. The correct answer is positive. All right, think about that. You won't be asked to discuss that in a test problem. You got to remember that if there's more than a non-trivial amount of uncertainty, you got to represent the uncertainty directly within the model. For example, in the readings, we have demand is not equal to the average. We have demand is equal to 1,000 sometimes and 1,500 sometimes. We have random demands within the analysis. Let's go back to the class map. We'll look at 5 different ways of representing uncertainty. Uniform between 0 and 1. We use the RAND worksheet function, open close parentheses, even though it has no arguments. What other worksheet functions have I covered that have no arguments but require parentheses, open and close?
Today function,
Say it again.
today,
No, I'm talking about it in this course. This is the first one today, and I have mentioned some others. Data validation, I think that was last Wednesday. I talked about only values within the past year are allowed. I used the today worksheet function. Equals today, open, close parentheses. Another one is equals now, open, close parentheses. Today ignores the time of day. It just gives you a date, a day of the year. Day 1, day 2, day 3. Time, for example, today is the 22nd, isn't it? Today, now would return 3:49 p.m. on February 22nd. Today would return February 22nd with no time component. All right, we use the RAND worksheet function. All values are equally likely. You're just as likely to get 0.1 as you are to get 0.2, 0.3. Actually, there are about 16 digits. Simulation models use these 0 to 1 numbers to generate other random numbers. The RAND is fundamental to what we're doing. Most of the time, the RAND is used indirectly. Sometimes directly, but most of the time indirectly. Uniform between any 2 numbers. Give me any 2 numbers which are not equal, and one of them is small and the other one is large. For example, machine processing time is uniform between 15 and 20. It is equally likely to be anything between 15.000 up through 20.000. For example, it could be 16.789. It could be, could not be 14. It could be 18.2345. We're going to use this formula. The small number, 15 and 20. S is 15, the small number. L is 20. We're going to use the small number plus the range. The range is 20 minus 15 is 5. 15 plus 5 times the RAND. The smallest the RAND can be is 0. 15 plus 5 times 0 is 15, is the smallest simulated machine processing time we can get. The largest the RAND can get is 1. So we would simulate 15 plus 5 times 1, getting 20. And of course, RAND is usually between 0 and 1. So we would get something in the middle. Let me mention in passing that the RAND cannot really equal 1. The largest it can be is 0.999999999. We are not physicists weighing electrons. Managerial issues don't care about the 16th decimal place. For all practical purposes, for all practical managerial purposes, 0.9999999 is close enough to 1. So we say between 0 and 1. RAND between 0 and 1, even though that's not quite true. It never quite gets to 1. It only gets to 0.999. We don't care. Let me give you 3 minutes to review what I've said so far. What gets wetter and wetter as it dries? You use it every day, I hope, a towel. Thanks to my grandson. I couldn't guess the answer, FYI. Here's an easier one. I think you might be able to guess the answer. What do you call a really old snowman? Water. I hope those are laughter, gasps of laughter and not gasps, not groans. All right, let's go on. Let me try to motivate you by showing you an alternative application of a concept that we're going to be using. The concept is quite unusual, VLOOKUP of a RAND. Here's a reasonable situation. In a few years, your company is considering spending a lot of money for a new software package. You have several competitors trying to sell you different software to do the same thing. You want, your boss has tasked you to compare the software on a representative set of customer sale records. But you're not willing to use actual data because it's proprietary. So you need to quickly come up with 1 million records. By quickly, I mean in 2 minutes, come up with 1 million records. That's actually doable. Let's simulate reasons for customers calling us. Customer 1, 2, 3, 4, 5. The possible reasons to call us to order new products, to question their bill, to report a change in their billing address, their home address, to make an appointment for a telephone support, or to ask for technical support right now. I'm assuming each one of these is equally likely. I don't have to assume that, but I'm gonna assign 1/5 as the likelihood that a customer is calling for any one of these reasons. 5 possible reasons I identified. Each one has probability 1/5. I'm gonna take the range of numbers from 0 to 0.2. 0.2 is 1/5. 0.4 is 2/5. 0.6 is 3/5. If a random number lies between 0 and 0.2, we say the simulated reason for the customer to call is to order new products. If the random number is not between 0 and 0.2, but if it is between 0.2 and 0.4, the simulated customer is calling for billing information. 0.4 to 0.6 means the customer is calling for a change in address. 0.6 to 0.8, make an appointment, 0.8 or larger technical support. We are going to VLOOKUP RAND. And we'll copy that down 10,000 rows, 100,000 rows, 1,000,000 rows, whatever we want. And in pretty much the blink of an eye, we create 1,000,000 fields within the record. VLOOKUP of a RAND. The random number must have been between 0 and 0.2. I don't show that. The second call is for billing info. It's a coincidence that the first possible reason the first customer is calling for. The second customer is calling for billing info. That's the second possible reason. But that's just an aberration. To make an appointment, the third customer is calling for the fourth possible reason. The fifth customer is calling for the second possible reason. VLOOKUP of a RAND. Let's see another example, again, for the context where you need to evaluate software. The sales representatives are myself, my wife, and various colleagues and nephews and nieces. If I have to make up a bunch of names, why not make up names that'll put a smile on my face? I'm going to say each one is equally likely. There are 10 possible sales reps there. So I'll use intervals of 1/10. 0.1 is 1/10. My interval is 0 to 0.1. I'm going to use equals VLOOKUP of RAND in the range E32 to F41, comma, the second column. Every time the random number lies between 0 and 0.1, as it apparently did here, you get me. 0.1 to 0.2 is Marguerite, my wife. Various colleagues and relatives. VLOOKUP of RAND, interval form, VLOOKUP of RAND in this range. Left column is the compare values, comma 2, interval form. The previous example was VLOOKUP of RAND, H2 to I6 absolute for copied in down, comma 2. Now let's look more carefully. I do review the VLOOKUP. If you have forgotten it, please study it right there. Pounds shipped, I use the same example as the previous one. Classic application of VLOOKUP. VLOOKUP to simulate future cash flows. Let's go back to the class pack and see where we stand. I'm on page 46. I think that I will need $20,000 next month with probability 0.3. I also think I might need 25,000 with probability 0.25. Or 30,000 or 35,000 or 40,000 with these given probabilities. Based on analysis of past requirements and my judgment as to we have new products coming out and competition is getting stiffer. So I don't expect as much money, but I do expect a lot of money for advertising expenses. Not in this course will I motivate why I think these needs. Empirical distributions. I specify as many possible values as I think appropriate, along with their corresponding probabilities. The probabilities are all positive and sum to 1. Let's notice that 20,000 is more likely. It has 30% probability, whereas 40,000 has only 10% probability. 30,000 has 20% probability. I'm going to use these probabilities to create lookup compare values, intervals. I want intervals so that 30% of the time, why 30% of the time? Because that's the given probability. I want 30% of the time the random number to lie in the interval, and that interval is 0 to 0.3. I want 25% of the time cash flow to be 25. 20% of the time cash flow to be 30, 15% of the time. My second interval has length given by the probability. My first interval has each and every interval has length given by the stated probability. The first interval has length 0.3. It starts at 0 by default, so it goes 0 to 0.3. The second interval continues from 0.3. The second interval continues from where the last interval left off and goes on for a total of 0.25. So I construct 0.3 to 0.55. The third interval starts where the second interval left off, 0.55, and goes up to 0.75. 0.2 is the length of the interval. The next interval has length 0.15, namely 0.75 to 0.9. And the last interval has length 0.9 to 1, which is length 0.1. It's called the Monte Carlo method. Let me digress a little bit. You ever play roulette? A roulette wheel has 38 slots, I think. 0 and double 0, and 1 through 36, a total of 38 slots. If we didn't have Excel computers, we could use mechanical or physical simulation. We could spin the ball, spin the wheel, and move the ball around and see where it lands. If it lands on 24, then we say customer demand is 24. The Monte Carlo distribution is similar to the concept of roulette. And Monte Carlo was a famous gambling center in Europe on the Mediterranean. Hence the nickname came and stuck, Monte Carlo simulation. We'll look at the details in a little bit later, but I do want to, well, let's see. No, I'm not going to jump ahead. We will look at the details now. Sim newspaper review. So I motivated in H1 over to the right a non-traditional use of VLOOKUP of a RAND, just so you'd be motivated to learn VLOOKUP of a RAND. VLOOKUP of RAND, as strange as it seems, it has this usefulness, generating representative records to test software. I review the classic VLOOKUP. Now let's look at VLOOKUP to simulate cash flows. We are given the probabilities, 0.3, 0.25, 0.2.15, 0.1. The VLOOKUP compare values are calculated starting at 0 and going up. I add the first probability, 0 to 0.3, given the probability. 0.32, 0.55, because of the next probability is 0.25. 0.55 to 0.75, etc. 30% of the time, a random number will lie in this range, 0 to 0.3. 25% of the time, a random number will lie in this range, 0.3 to 0.55. In B28, I have equals rand, and in the other yellow cell, I have VLOOKUP of that random number. 0.94 lies in the interval 0.90 or bigger. Therefore, we simulate 40,000. Let's recalculate F9 or delete key. I get a half. Surely you were looking at different numbers. 25, let's see, 0.53. Does it lie between 0 to 0.3? No. Between 0.3 and 0.55? Yes. So 25 is the simulated cash flow. Recalculate, 0.76 lies between 0.75 and 0.9. 35 is the simulated cash flow. That's what we will be doing to implement the empirical distribution. Let's back up and look at the class pack. Let me go to page 45. I'm going to look at these 5 techniques. Uniform 0 to 1, uniform any given number to any other number, such as 15 to 20. Empirical, we just covered that. Normal, and then the if in conjunction with the rand. Normal distribution. From statistics, we use the mu as the symbol for the mean and sigma for the standard deviation. It's almost universal. You recognize that? No, you did have core statistics, didn't you? Or you exempted it, right? Look in your statistic notes. And talk to me outside of class. You don't need to know much about it. Norm.ind is the name of the Excel worksheet function. That's the inverse normal function. The 3 arguments, a random number between 0 and 0.9999, between 0 to 1, a random number between 0 to 1, the mean, and the standard deviation. Finally, if and rand worksheet functions, that's the example that I asked you to read before class. Remember how I started? Sales will be 1,000 most days, but 1,500 on other days. Equals if logical test, like rand is less than or equal to 0.75, then 1,000, otherwise 1,500. Let me read to you some excerpts from a JP Morgan Reuters software manual. It uses the term simulation to determine a set of likely interest and foreign exchange rates. Simulation will, well, interest rates will be simulated and foreign exchange rates will be simulated. For each scenario, a portfolio value is computed to get a distribution. Correlated normal random variables are used in the simulation. Continuing, it talks about the Monte Carlo methodology for 3 major steps. Scenario generation, portfolio valuation, summary, simulation. It shows a picture of the normal density and the normal cumulative distribution function. You don't have to know any of that. What you need to appreciate is that simulation is valued by JP Morgan Reuters to the point where they discuss it. When you're a senior manager in a few years, you may be asked to sit on a committee to evaluate the use of simulation for your company. And you should have some exposure to what simulation is. You know Vikram Tawari? He's an employee of the medical school, an analyst. He teaches a couple of courses, healthcare operations, something like that. One of them is for the MMHC students, the Master of Management in Healthcare. But he teaches an MBA course in which he teaches identical concepts as we do here. Students do a simulation project for Vanderbilt University Hospital. We can look at this page later. All right, normal probability and in class. Let's go to the A1 in sheet, normal probability and in class. In column A, I want to simulate normally distributed random values. with mean 1,000 and a tiny, tiny standard deviation, 2. All of the simulated numbers will be very close to 1,000. That's what it means. Well, the English language is lacking. The mean is 1,000. The standard deviation is 2. And now I want to use a verb. This is what it means. This is the interpretation. The interpretation of a tiny standard deviation is that all of the values will be very close to the mean. The mean means the average. Gee, English is a tough language. All right, the next example has identical mean, identical average. I'm going to say mean because that is the technical statistical term. But a huge standard deviation. Although these numbers will average 1,000, there's much more dispersion in column B. The individual values are much farther away from the mean. 906, 1,042, 555, 1,127. That's a huge dispersion as shown by the quantified standard deviation. The average, I'd have to do more than 35 or more than 25, whatever I have. Nothing is testable except the examples that we do, the in-class problems that we do. Let's start with these 4 green cells. Delivery days. They could be anything between 3 and 5, equally likely, including fractions. It could be 3.5 days. It could be 3 1/4 days. It could be 3.5, 6, 7, 8, 9 days to deliver replenishment. I ran out of marker pens. I ran out of parts to manufacture engines, so I need to resupply. What is the Excel formula for anything between 3 and 5 equally likely? What is the Excel formula for interest rate next month? Could be 8%, or it could be 8.5%, equally likely. Work those first 2, please. Do I have a volunteer for the first one?
Equals norm.inv.
That's for the latter one. Anything equally likely is not norm.inv, not norm.inv. You're close, miss.
Your screen is off in the classroom.
Okay, thank you. I muted the picture while I pulled up my answer sheet. Zoomers, remote students, are you looking at my screen?
Yes, we can see it.
Okay, thank you. Any volunteer for what's the formula to simulate?
3,
Equally likely is the key. Go ahead.
3 plus 2 times rand.
Yes. without hard coding equals G11. I know that's what you meant. Plus, open parentheses, 5 minus 3 star G11, that's the small one, plus the range H11 minus G11 times the rand. In this case, I put the random number directly within the formula. In other cases, I use it in a separate cell. Either way is fine. If you recalculate, you'll get a bunch of numbers between 3 and 4. You know that if you have a formula which sums, SUM, sums up the cells in a range, and if any of the raw data change, the sum updates to reflect the new summation. Well, the RAND worksheet function updates as well. Whenever anything changes in the workbook, all formulas update, including the RAND. All right? 8% or 8.5%. Here's my answer, equals if RAND is less than a half, G14, otherwise G15. The if in conjunction with the RAND. Somewhat similar to the readings I asked you to do before class. I arbitrarily chose less than a half when I could have chosen greater than a half. It's comparable to taking a coin and flipping it. But before you flip it, heads means 8%, tails means 8.5%. Or you could have used the opposite convention. You could have said heads means 8.5% and tails means 8%. As long as you were consistent. So you could have used greater than a half means G14, less than a half means G15. For that matter, you could have used greater than or equal to, or less than or equal to. This is one of the few cases where it doesn't matter if you use greater than or greater than or equal to. It's considered inappropriate to ask the question, what is the probability that it will be exactly equal to this continuous number with 16 decimal places? So we don't care whether it's less than or equal to. Anybody want to try the norm.in? Someone volunteer that later. I'm not showing you the formula yet. Normal with mean 50, referring to, of course, G17, and standard deviation H17. What formula do you think I have in the green cell F17? Norm.inv, open parentheses, RAND, comma G17, comma G18. At a cocktail party, a woman told her friend, "You're wearing your wedding ring on the wrong hand." She said, "Yeah, but I married the wrong guy." Finally, empirical. It might be 10 hours of machine time, it might be 11, it might be 12, it might be 13. These are the given probabilities. These are the given values, 10, 11, 12, or 13. These are the intervals, 0 to 0.6, the first probability. 0.6 to 0.8, using the second probability. 0.8 to 0.95, the third probability. 0.95 or bigger. When you're looking up a random number, 0.95 or bigger is the same as 0.95 to 1. Because 1 is as big as the random number can be. Let's work our first problem. We're going to come back to these in class later. Newspaper simulation. You won the Owen School Founders Medal. So I'm in the same book, Sim Newspaper Review. Sheet, newspaper simulation. You won the Owen School Founders Medal for the highest grade point average. However, you studied so hard that you had no time for interviewing and you were jobless at graduation. As a result, you bought the newspaper stand at 5th and Broadway. You buy newspapers the day before. They cost you $1.10. You sell them for $1.50. You have to decide how many newspapers to buy the day before. Let me make a note of the time, please. 0.10 for example. We may not finish this quite today. You buy newspapers for $1.10 the day before, you sell them for $1.50. And if you order too many papers, they're useless to you. They have no salvage value, no recycle value. So if you order too many, you pay $1.10 for unsold newspapers. If you don't order enough, then you miss out on potential profits. So it's an important question, how much should you order? Set up a simulation model. Look at the possible values. In past 20 days, let's put A16 near the top left of each one. In the past 20 days, these were the sales. I sorted them. 260 newspapers were demanded on one day, day one. 332 on another day. 576 on another day. Let me show comments. Sim Newspaper Review. These are called comments on this version of Excel, but the exact same workbook calls them notes on my office computer. So again, 260 on day one, 332 on day two, etc. If you have 500 papers, you can't meet the demand of 576. You'll sell 500, 440, 348. Notice that some values repeat on day 5 and on day 16 and on day 19. Demand was 348. On days 11 and 14, demand was 400. Here are the same demands sorted. There are 20 days, so 1/20th is the probability that any one value will occur again in the future. 196 appeared once. So the compare interval VLOOKUP table has the first interval 0 to 0.05. 0.05 is 1/20th. I construct an interval with probability 1/20th, namely an interval with length 0.05 that corresponds to 196. I construct the second interval, 0.05 to 0.10, which again has length 1/20th that corresponds to the next possible demand, 260. Let's look at this heavy border interval. 0.4 to 0.55 has length 3/20. 0.15 is 3/20. 348 has probability 3/20 because it occurred 3 times out of 20 in the past observations. A long interval associated with values that have more likelihood of occurring, big probabilities. Let's look at the 0.1. I hope you can see the difference between the light gray shading and the dark gray. I cannot on the screen very well. I can't even see the 348. On your own screen, can you see F 25, 6, and 7 have a distinct shading of gray, but not as dark as the two 400s. Okay, I can see it here too, but it's lost over there. So these are my compare values. Step 1, get some demand data and sort them. Step 2, set up a VLOOKUP table. That's what we've just done. 0 to 0.05. Now I want to use large font, but I also want to make simultaneous display of some rows. So let me hide some rows. Here is the data. You pay, or your cost is $1.10 for each newspaper. You sell them for $1.50. And in red border, I have a changing cell. How many newspapers shall I order? 400 is my first guess at an answer. I will use simulation to tell me how good that answer is. I'm going to have to rush now. We will certainly come back and review this problem in its entirety. On day 1, please, let's look at row 49. I copied the values of the simulation of the random variables. You don't really think I typed all those digits, do you? And then all those digits in the cell beneath, and all those digits, and all those digits. I typed equals RAND open close. I copied and pasted special values so that we would all be looking at the same numbers. Data for teaching. Where the random number is 0.92 something, and that lies in this interval. Let me use color coding. I use red. 0.92 lies between 0.9 and 0.95. 440 is the simulated demand. The revenue, if you order 400 newspapers and customers want to buy 440, you sell 400. You sell the smaller of your inventory and the demand. On the next day, the random number 0.24, I'll have to find it up here, that's 304. We'll do this again, 304. And we have 400, so we sell 304. We ordered too many that day, but we ordered not enough the previous day. We will calculate our revenues, our costs. That cost is trivial. It's the order quantity stocked times $1.10. Let's go back and see what we have done. What is simulation? We are performing a simulation experiment on a model to see how uncertain customer demand impacts us. Why is it important? Because it occurs because often you have uncertainty. Uniform 0 to 1, we've seen these examples, and we're seeing our first real example. Simulation is descriptive. We will implement the uncertainty, we will represent the uncertainty directly within the analysis. We will have equals RAND, except that I copied and pasted the values. Simulation is prescriptive. Excuse me, linear programming is prescriptive. Simulation describes, and I'm not going to ask you these kinds of questions on an exam. Is simulation descriptive or prescriptive? I'm not going to ask you that. Especially this late in the course, you will be asked to solve problems similar to what I do in class or similar to the homework. We will specify, we will guess the answer is 400 and simulation will tell us how good that is. We will then guess another answer, like 500, and simulation will tell us how good that is. I hope you can sleep tonight without knowing the resulting outcome. Have a good day.
So you got. Oh, they got beaten up.
Lost this.
Jesus.